We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
Indicate chute deploy.
The navigation has confirmed that the parachute has deployed, and we are seeing significant deceleration in the velocity. Our current velocity is 440 meters per second at an altitude of about 12 kilometers from the surface of Mars.
Heat shield set.
Perseverance is now slowed to subsonic speeds, and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Nav filter converge. Velocity solution 3.3 meters per second. Altitude 7.4 kilometers.
Now has radar lock on the ground. Current velocity is about 100 meters per second, 6.6 kilometers above the surface of Mars. Perseverance is continuing to descend on the parachute. We are coming up on the initialization of terrain relative navigation and subsequently the priming of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2 kilometers.
OBS valid.
We have confirmation that the lander vision system has produced a valid solution and part of terrain relative navigation.
Priming. TBA is nominal.
We have priming of the landing engines.
Back shell set.
Current velocity is 83 meters per second at about 2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated. We are currently performing the divert maneuver. Current velocity is about 75 meters per second at an altitude of about a kilometer off the surface of Mars.
TRN safety Bravo.
We have completed our terrain relative navigation. Current speed is about 30 meters per second, altitude of about 300 meters off the surface of Mars. We have started our constant velocity accordion, which means we are conducting the sky crane, about to conduct the sky crane maneuver. Sky crane maneuver has started, about 20 meters off the surface.
We're getting signals from MRO.
Tango Delta.
Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the sands of past life.
And I'm going to talk to you now with this. This is the microphone that was part of the EDO camera system. When the EDO cam system was first envisioned, it was set up as just a bunch of cameras to capture some amazing imagery on the surface of Mars. And about a year or so after it was first conceived, I got a phone call, another call from Matt. After talking to headquarters, asked the question, could we possibly put a microphone as part of our EDO camera system? So we worked with the team, we took a look, and sure enough, it was something that we could do. And so we started off that detailed design and identifying a microphone that would work for us and getting it onto the vehicle. About a year after this first started, I'm giving a tour at JPL. And I happened to mention to the group that I was giving the tour to that the decision had come down and we were working to actually include a microphone onto the vehicle. And after the tour was done, a gal came up to me and she said some things to me that I won't forget anytime soon. She said, I'm super excited that you guys are going to try to put a microphone onto the rover and get it to the surface of Mars. And I was very appreciative. And I asked her afterwards, I said, I'm curious, why is it that this relates to you so much? And her response was that her sister was visually impaired. She was not able to see these images that we saw earlier or that we sent down in the past. And while she tries to describe them to her, she felt that she just can't quite capture that same sense of amazement that she gets when she gets in visually. And that by actually getting a microphone onto the surface of Mars, the hope was that she'd be able to experience things on Mars the same way that she was when she actually looked at them. And that stuck with me. We continued to work super hard to make sure that this microphone would work. And that's part of the reason we were disappointed why it didn't work when we actually went and did our entry, descent, landing sequence. I wish I had actually captured that individual's name. I would love to reach out to her now and say, we've done it. I hope your sister is enjoying it. Because what I'm going to show you in a second, or what you're going to hear in a second, is actually the first sounds being recorded from the surface of Mars. So there are two microphones on the Perseverance vehicle. There's this microphone here, which is part of the entry, descent, and landing system, and there's a second microphone that's on the SuperCam instrument. And we're counting on both of these instruments recording some absolutely amazing sounds from the surface of Mars. So with that, I invite you now to, if you would like to close your eyes and just imagine yourself sitting on the surface of Mars and listening to the surroundings. If I could have the first one, please. So that gentle whirl that happens in the background, that is a noise made by the rover. But yes, what you did hear 10 seconds in was an actual wind gust on the surface of Mars, picked up by the microphone and sent back to us here on Earth. The analysis indicates that was around a 5 meter per second type of wind gust. So we can sit here now and actually tell you that we have recorded sounds from the surface of Mars. So we have a second one, which basically further reduces the noise of the rover, so you can just hear what the wind would sound like on Mars. And once again, I invite you to sit back and have a listen to what it would sound like to be on Mars. It's cool. It's really neat, overwhelming, if you will. I can't remember what I was going to go and say next. So looking forward to doing some amazing things with the microphones going forward. We need to work with the ops team. There's some great science that they're looking to do. We're hopeful that we continue to use these microphones, both the SuperCam microphone and the EDO cam microphone, to capture sounds, perhaps the rocks interacting with the surface. SuperCam is going to use theirs to get some great data of them zapping rocks. So as you've heard and will continue to hear, we're just beginning to do amazing things on the surface of Mars.